Dear student, today I am going to cover a new topic of drug action and drug mechanism of action. In last class, I have already discussed about drug action, means how the drug is going to show its action by different types of action. Like I told you, drug action is comes under by pharmacodynamics. That drug action is different mechanism are there. So drug, how they can show their action, that we have already discussed in the last class. What we have studied, that drug action, it can be shown by depression, it can be shown by stimulation, it can be shown by replacement, it can be shown by cytotoxin, and also it can be show its action by irritation or inflammation mechanism. All that I have discussed in the last class, and today and last class only I have told that all that things are the type of how drug is going to act. You can tell all these are the result for the action of drug. When drug acted, all that results comes out. So that are all the result and all the type how drug is going to act and what are the purpose of the drug action and how the drug is showing their action by this. That is called as drug mechanism of action, that we are going to explain in the upcoming classes. Today I am going to explain the brief and introduction about drug mechanism of action, how it is going to show its action, and what are the components that are going to help drug in doing or showing their action in particular site of action in our body. So drug mechanism, what that means of drug mechanism, that means how the drug is going to show its action, where it's going to show its action, and when it's going to show its action. So mechanism of action is where the drug is going to show its action, how it is going to show its action in a specific part of the body, where it is going to show, and why it is going to show, and who are the component and which are the component that are going to help the drug in showing their mechanism of action in our body, what are the components of our body which are helping drugs. So in drug mechanism of action, first we have to remember before going to into the deep, what are the component in our body, what are the component in our body is going to help that drug in showing their mechanism of action into our body. So that components are generally proteins in nature, and that drug generally bind to all these protein present into the body, which are act as helping material or helping component for drug, bind with the drug and so help that drug to show its action in specific site of action when we are taking a drug for a desired therapeutic effect. So now we have to know, or you have to know what are the components, that means what are the proteins and what are the other components of our body helps drug in showing its mechanism of action. That are enzymes, 2 receptor, third ion channels, and fourth transporter. So we will discuss one by one how that component of our body helps a drug to bind in specific part of the site and show its desirable therapeutic effect. The first component is enzyme. So how that enzyme is going to show its action by binding with the drug and helps the drug in showing its mechanism of action. We all know enzymes are catalytic component or chemicals of our body which helps in speed up of the action but doesn't participate in action directly and after the reaction they stay unchanged and unionized and unformed, and they only work is to boost up the speed of action. And we all know enzymes are generally protein in nature. How that enzyme going to act, now we are going to see. Enzyme generally act as lock and key mechanism. And how it is acting, whatever drug we are taking, that is act as substrate. That enzyme, what it will do, that enzyme will form a complex with the substrate, and it will form enzyme substrate complex. How it is going to form that action, just suppose that is one enzyme, it is the active site of enzyme. So now what will happen, that substrate which have the particular size or shape like that active site of enzyme, they will bind with that enzyme, and that will form enzyme substrate complex. And that substrate, how it is going to act or how it is going to sit in that action site, that can be classified into two. If there is a presence of inhibitor which are going to inhibit the action of substrate, then it can be inhibitors or it can be substrate that will occupy that action site. If that inhibitor and substrate both competing with each other, and then they are going to sit in that action site, that means they are doing competition with each other. That time it is called as competitive binding. But when there is no inhibitors, that time substrate don't have to compete with anyone, and that substrate can easily sit on that action site of enzyme. So there is no requirement of competition. This is non-competent or non-competent enzyme induction. So by competitive or non-competitive, if that is competitive, inhibitors and substrates, they will fight with each other, and then they will sit on that active site of the action anyone. And if there is no inhibitor, then substrate without any competition, it will sit into the action site of the enzyme, and it will help that drug in showing their particular desired action when they will go to their desired site of action. If there is inhibitors, and if that inhibitor is going to bind with enzyme, and if that substrate are failing to bind with enzyme, that time what will happen, that time it will show adverse effect. That means you have to remember, if that substrate is directly or by competitively anyhow, if that substrate is going to occupy that space of action site or active site of that enzyme, that time it will show desired action or the therapeutic action for which we are going to take the drug. But if that inhibitor wins the race and competitively fight against substrates, and that inhibitor sit inside that active site of the enzyme, that time it will show adverse effect, or that we call as undesirable effect. So by this I just explained easily how that enzyme is going to bind with drug and going to show its action in a specific site of action, how it is going to show their desired action, or how that it can show adverse effect. All that I have discussed in that portion. So the next component which are going to help drug in showing its action in specific part of the body, that is ion channel. We know what are ions. There are different molecules present in our body, different like what we have required in our body: sodium, potassium, calcium, some kind of magnesium. We know magnesium help in glycolysis, all these things. When they release their charge or accept their charge, and they are going to produce in ion, that all are molecules. When nitrogen is removing one electron, that time sodium will charge into Na plus. So that Na plus is a ion. What K plus will do? K plus also will remove one electron and it will change into K plus ion or potassium positive or cation ion. Chlorine, what it will do? It will accept one electron and it will create Cl minus ion. And magnesium, it will take not, it will remove or it will eliminate two electron and it will be changed into magnesium 2 plus or magnesium cation ion. In our body, for whole or for all that ions, there are different channel present in our body. Like just explain, that is one channel. Just think that is sodium channel. Here one gate are there, one gate is there. If that gate is there, that means that sodium ion can't enter inside, or if it is present inside, it can't go out. So if that drug is bind with that ion and that channel is closed, then that drug and ion can't enter into that channel and can't enter into the site of action. If that channel is open, that means that drug which are present or which are binded with that sodium or any ion, that channel can, by through that channel, that ion with that drug can easily enter into the site of action and can show its action. So that is how a ions is going to show its action and bind to drug and show its action. That means you have to remember all specific ions have their specific channel. If the channels are open, then the drug and binded ion can easily pass through and easily can go to the action site and can show its therapeutic effect. And if that gate is closed, then that drug with that molecule or that ion, it can't pass through that membrane and it can't reach into the action site and it can show its action. That means I just show it how ion channels are going to play an important role, how that drug will bind to that ion and how that drug will pass through that gate or channel, then it will enter into the specific site or action site and it is going to show its therapeutic or desired action. So I have told you how enzyme and ion channel is going to play a important role in binding drug with that ions and enzymes and going to show its action in specific site of action. The third part is transporter. Transporter means we can understand by its name, who are helping in transport called as transporters. How the transporters is going to act? The transporter will transport a drug by binding with it and going to reach into the specific site of action and going to show its action. How it is going to show? Just suppose transporter is like that. So now what will happen? That drug will come and will bind with that transporter. Now what that transporter will do? That transporter will rotate downwards. When that will rotate downwards, that will be like that. So now that drug will be binded with that transporter and it can't be fall out from here. So it will be tightly bind with the transporter and like that by rotating it will start to transport from one place to another place and is going to reach into the specific site of action and going to show its mechanism of action. That is transporter help. One example is sodium, potassium, ATPase transporter, or you can tell sodium, potassium and calcium transporter is an example of transporter which is going to bind with drug and reach into the specific site of action and going to show its mechanism of action. The last and the most important component that is going to play major role in binding with drug and showing mechanism of action of drug in specific site, that main or important component is receptor. Receptor is most important in our body, which are helping drug in showing its action. If our body don't have any receptor, then it is not going to show any action, or it is drug is going not going to show any action. So to show a drug their action, a receptor is most important to bind with drug to show its mechanism of action. So that receptor is very important, and it is itself a very vast syllabus or a very vast chapter. So in upcoming classes, one by one, I will discuss about all of the receptors which are present in our body, which plays a very important role in showing specific action in specific site of action by specific drug. All that receptors we are going to discuss one by one later. Today I am just briefingly just shortly are telling how that receptor in simply it is going to bind with drug and going to show its action, and what are the types present, what are the types of receptors which are present in our body. So what is receptor? Receptors are the physical and chemical substance in our body or component of our body that is going to receive and going to respond to electrical signal in our body. What are their main work? Their main work is to bind with hormone, bind with drug, bind with neurotransmitter, and help them in showing their different action for which they are present in our body. Drug also, to show its specific mechanism of action, it should be bind with a specific receptor so that that drug can show its mechanism of action in a specific site in a specific manner by its mechanism of action and going to show its desired therapeutic effect. Now, what are the types of receptors? The types of receptors are four types. One is GPCR, that is called as G protein coupled receptors. The second type is enzyme linked receptors. Third one is ion channel gated receptors. So all that are receptors present in our body. In our body, most of the receptor, almost 60 to 70% of that receptor are GPCR or G protein coupled receptor type, and others are also there like enzyme links, ion gated. All other receptors are also there that are going to play an important role in our body to show not only drug, different what are the components are present in our body like hormone, neurotransmitter, how they are going to show its action. All is depend upon which are the receptor is present, with which receptor they are binding, and depending upon that thing, it is dependent how they are going to show its action. So all that receptors are very big chapters that I am going to explain one by one into the upcoming classes. In upcoming classes, I am going to start about the general introduction of receptors and their types and their specific types. One by one I will explain in brief into the upcoming classes. Thank you.